Hello again, and welcome once more to a video introduction and illustration of IBM's WebSphere Application Server for ZOS Optimized Local Adapters, or Wola for short. This is the outline for the subjects covered in this 5-part series on Wola. In this section, we'll cover how Wola operates with IMS. IMS support for Wola became available starting with the 7.0.0.12 release of maintenance for WebSphere Application Server for ZOS. IMS has a long history and is a functionally rich product. It is used extensively in very high throughput environments. On this chart, we will walk through, at a high level, the various ways in which Wola works with IMS. We start with a server instance of WebSphere Application Server for ZOS. The first form of IMS usage we'll illustrate is an IMS batch controller running batch DLI applications. This model very closely mirrors standalone batch use of Wola. The Wola APIs are made available to the IMS controller region, and the DLI applications write to the Wola APIs to perform inbound or outbound processing with WAS. The next form of IMS usage we'll illustrate is inbound to WAS using the IMS External Subsystem Attach Facility, or ESAF for short. ESAF may only be used for inbound calls. It cannot be used for outbound calls from WAS to IMS. This is due to the design of the ESAF interface. The ESAF support may be used with Message Processing Program Dependent Regions, or MPPs for short. Or it may be used with Batch Message Processing Program Dependent Regions, or BMPs for short, or an IMS Fast Path Dependent Region, or IFP for short. In all cases, the programs in the IMS dependent regions must write to and use the Wola APIs. Enabling the Wola ESAF support involves a few relatively simple IMS system programmer steps. They are spelled out in the Product Info Center under the search string TDAT Enable Connector IMS. As noted, the use of ESAF was limited to inbound only. But you may access MPPs, BMPs, and IFPs both inbound and outbound by circumventing the use of ESAF. This results in a model that's more closely related to standalone batch or IMS batch controller DLI programs. The next form of Wola usage we will illustrate is Wola over OTMA. This is limited to outbound calls only. This is due to the design of OTMA. MPP, BMP, and IFP dependent regions may be used with Wola over OTMA. In this model, the programs in IMS are shielded entirely from any awareness of Wola. They are shielded by the IMS OTMA interface. In this usage scenario, Wola in WAS is not talking directly to the programs in IMS. Rather, Wola is making use of the OTMA interface of IMS to piggyback into IMS. Because of this, the performance you will see with Wola over OTMA is limited to the performance of OTMA itself. You get ease of use and flexibility, but at the expense of the pure Wola performance you'd see by writing directly to the APIs. You may bypass OTMA for outbound calls and instead write your program to the Wola native APIs and the host a service function they provide. That will provide you with the performance benefits of Wola. But here are some considerations we wish to bring to your attention. First, for performance reasons, we recommend the use of the asynchronous APIs. In the video section on the native APIs, we call these the advanced or the primitive APIs. The simpler synchronous APIs hold program control while a response to a message is being processed. That makes programming easier, but the time spent blocking program control, even if it's just a tiny fraction of a second, adds up when thousands of messages are being handled per second. The asynchronous APIs allow you to squeeze the maximum performance out of Wola. For IMS fast path and batch message processing programs, the issues of synchronous versus asynchronous is less of an issue, since those are examples of single-purpose dependent regions. The asynchronous APIs, properly used, will yield greater performance, but the synchronous APIs will work well with IFPs and BMPs. For message processing programs, we strongly recommend the use of the asynchronous APIs. That's because the synchronous APIs will result in critical thread resources being tied up in the message processing region. IMS is by its design a high-performance, high-throughput subsystem. If you're using IMS, you very likely wish the best performance possible. That's why we recommend the use of the non-blocking asynchronous APIs. For IMS fast path and batch message processing regions, it is not quite so critical. But for message processing regions, the use of the non-blocking asynchronous APIs is essential to avoid tying up thread resources. Here's a summary of the security and transactionality support offered with Wola and IMS for the various usage scenarios we just illustrated. For outbound over OTMA, you may assert the identity of the WAS thread for MPP and IFP, but not for batch message programs. At the present time, transaction is limited to sync on return or confirm only. If you bypass OTMA, you achieve better performance, but you may not assert the WAS identity or have any transactional propagation. That may be acceptable based on your requirements, so review what your design requires and architect your Wola solution accordingly. For inbound over ESAF or direct using the Wola APIs, you may assert ID on the IMS thread, and the only option at the present time for transaction is sync on return.